Hey folks, Mr. Hempstead here, back with another great one. Today we're going to be talking about motion graphs. Specifically, our target is to be able to interpret data represented by graphs that measure distance, speed, and time. So before we really get into today's target and before we really get into the meat of this lesson, I always think it's important to talk about why. Why are we learning about graphs? What makes graphs so important? Why are we learning how to interpret graphs? And since interpreting graphs is today's target, that's kind of the question that I want to start with, is why do we need to be able to do this? I don't know. What do you think? Why do we need to be able to interpret graphs? I can share with you what I think. There's a lot of data in our world. Presidential elections, there's a lot of data surrounding that. Climate change, there's a lot of surrounding that. Statistics, analysis, businesses, predicting things that are going to happen in the future. Distance and time graphs, right? There's a lot of different kinds of graphs out there, and being able to interpret graphs gives you access to a lot of information that you wouldn't otherwise have. So they're really powerful because we use them all the time. Okay. Why do we need to be able to make graphs? Another good question. Why do we need to be able to make graphs? Why is that important? What do you think? Once again, I can share with you what I think. I think we need to be able to make graphs because, once again, we use graphs all the time. And if you know how to make graphs, you can share and present information better. You can talk to people about things they wouldn't otherwise understand. You yourself can understand data better. Excuse me. Okay, so with that being said, let's start hitting today's target and learning how to interpret data represented by graphs, specifically measuring distance, speed, and time. Okay, this is the general layout that you're going to see for a graph. There's going to be what's called an x-axis right here. This little space right here, that is called the x-axis. In a distance versus time graph, time will always be represented by the x-axis. Additionally, you're going to have another axis. This axis is called the y-axis. And the y-axis is represented by distance, at least in a distance versus time graph. Another thing that distance versus time graphs have is they have units. Notice how I've labeled both my x and y axis with a title and the corresponding unit, because it makes a huge difference. If we're measuring a runner who isn't running at a speed of 2 meters per second, but they're running at a speed of 2 miles per second, that's a significantly different number. It's going to be a significantly different graph. So our units are important. Lastly, it never hurts to have a title. Okay, so speaking of this runner running at a speed of 2 meters per second, how would we graph that runner in our graph? What do you think? How would we graph a runner traveling at a speed of 2 meters per second in our graph? Would we have a flat line? Would there be a line going up, a line going down? What do you think? We would have a line going up. So the next question is, how do I determine how steep of a line do I make? Do I make a line that's just in the middle? Do I make a line that's going up a lot? Do I make a line that's not going up as fast? How do I determine where to plot my line? Well, I use a really cool tool called rise over run. How rise over run works is we're going to take our number and our graph is going to rise that many squares. And then we're going to take effectively the bottom number, and that's the run. let me show you what I mean by that. Here, we'll get rid of these lines real quick. So I have a speed of 2 meters per second. So what would happen? Let's say our runner starts at the origin. They start at 0 meters in a time of 0 seconds. Makes sense, right? They're starting at the starting line. And then when they start running, after the first second, they've moved 2 meters. And that makes sense, right? Because if they're moving 2 meters per second, 2 meters per second, that's where they would be after 1 second. Okay, so then they would travel another 2 meters in 1 second. And another 2 meters in 1 second. Effectively, what we're doing is the rise 2 meters over the run 1 second. And effectively, we've got ourselves a graph. Cool. I'm going to quickly add in a couple other graphs. Here's one. Here's one. And here's one. And let's just quickly label these graphs. And we're going to see how well you guys do at identifying what do these different graphs mean. We'll call them A, B, C, and D. Okay. So let's say our runner isn't moving at a speed of 2 meters per second. Let's say they're moving at a speed of about half a meter per second. Which one of these lines best represents the speed of our runner now? It's D. And the reason we know this is because of the rise over run. So our runner runs half of a meter in their first second, and then they run another half of a meter in the next second. And this pattern continues all the way up my graph. Pretty cool, huh? All right. So, not all graphs are perfectly straight lines. For example, what happens if the speed of a person changes? This can be kind of interesting. Let's say we've got a very tired runner. So for the first 5 seconds of the race, their speed is 0. They're not moving. What do you think that would look like? Would it be a line going up really fast? Would it be a completely flat line? Would it be going up a little bit, maybe down a little bit? What do you think? What would their speed, if they had a speed of 0, what would that look like in this graph? So if they had a speed of 0, it would be a perfectly flat line because there's no rise. They're not moving any distance. The rise over run after, the first second, they're still in the exact same spot that they were. And so for the first 5 seconds, our person is not really running at all. There we go. See if we can make that a little, oh, that's way too big. Way too big. There we go. Right in the middle. Okay. But then, our runner, they wake up a little bit. So they start moving at a speed of 1 meter per second. Now we go back to that rise over run. So they run a meter in 1 second. There we go. They run another meter, 1 meter, after another second. And they continue that pattern all the way across this graph. That's my wife.
So the worst part was the week before I had.
There we go. Okay. All right. So now that we've done a little bit of interpreting graphs, let's try a few practice problems and see how you guys are going to do. My first question for you guys is, does the runner accelerate in this graph? What do you think? Yes or no? The answer is yes. The runner does accelerate. When they are at 5 seconds, their speed increases from 0 meters per second to 1 meters per second. So our runner's speed increases. Let's try a few more practice problems. Here's another graph, once again describing a runner running. Okay. So is there any point in this graph where this, here's a good question. Is there any points in this graph, A, B, C, or D, where the runner is not moving? Yeah. At B, our runner is standing perfectly still. Okay. Is there any point in this graph where the runner is moving really fast? What's the fastest this runner is moving? So in line C, we can see that the rise over run is 3 meters per 1 second. Let me show you exactly what I mean by that here. It goes up 3 boxes for every 1 box it goes over. So what that means is the rise over run is 3 for every 1 second, or 3 meters per second. Cool. And that's the fastest our runner is ever running in this diagram. Is there any point in this graph where our runner is accelerating? Where? If you look in between B and C, our runner is going once again from a speed of 0 to now a speed of 3 meters per second. And so we can clearly see that our runner's speed accelerated because it increased. They're running faster when they transition from B to C. There you go. Hope you guys enjoyed today's video. Hope you found it useful and informational. I'll talk to you guys next time. Bye now.